In this video session, we will be discussing about the importance of material properties and type of material characteristics which you have to assign before proceeding for solutions. So, if you see the analysis, it consists of the material property as the primary part. The material having two different properties like the linear, where the material's property behaves typically within the elastic limit, and inside the plastic limit it behaves in a different manner. And if you see nonlinear material is also like the creep data and stress and strain data, because you have multiple ratio between the Young's modulus and Poisson's ratio that you have to interpret to understand the nonlinearity, and directly you can import those properties to ANSYS library like this, the material library path, which directly you can configure here the material properties, material library and library path. You directly can configure by using the browse, and you can load it, and this will be given when you do the project. It is company specific, and whatever the material they use that you need to configure, or else you can define your own material under structural, thermal and other conditions. If you go to the material, you have the linear and non-linear, and under linear you have elastic and isotropic, orthotropic and anisotropic as well. And all these principles I will explain. And you have to set the unit of ANSYS very precisely. If you see by default SI, you can switch to CGS, the British unit, or British unit feet, or British unit inch, or user defined. And if you see the unit dialog box, the length in SI unit is in meter, and mass is in kg, and time is in second, and temperature is in K, that is in Kelvin. And in CGS system it is degree centigrade, and feet and inch unit, it is corresponding units are specified here. In case of user, you can specify your own unit configuration where you need to depend on this principle, and you can even go for the length as mm and mass as kg, time as second and temperature at degree centigrade. So you can configure as per your requirement, that is user. How to do this, that I will show you. If you go to the unit system, that directly you can see here the material library, and you can see select unit, you can select the user, and as per your requirement you can set it. And if you change the unit of measurement for angular units, you can also set here degrees or radian, and you can set also the temperature unit whatever you need, Kelvin, Celsius or Fahrenheit. So after comparing this required unit, you can start your analysis. You can locate the material by assigning a number and by connecting to the material library. This particular principle I will show directly here. If you see the material number, and when you configure the available material, that particular number will be integrated to that. If you are talking about isotropic material, if you talk about orthotropic material, if you talk about anisotropic, certain principles are governing this material. In case of isotropic, the materials are homogeneous and uniform. You have single Young's modulus and Poisson's ratio. In case of orthotropic material, you have directional dependent Young's modulus, and you have multiple Poisson's ratio. Those are known as major and minor Poisson's ratio. And like orthotropic and isotropic, you have another kind known as the anisotropic material, which is known as the sandwich material, and you can see composite conditions over layers and layers. You have different behavior. The wood is one of the best example to describe anisotropic property. And just like that, you have nonlinearity material as well. You have the Young's modulus and Poisson's ratio when you talk about the material definition. If you go to the material model, elastic, isotropic, you can see the Young's modulus and Poisson's ratio, which are the primary definition parameter which you have to set. And here you can see the material number. If you go to the new material, the new numbers will be assigned. Based on this material number, you control the characteristics and principle which you define during the project. And you can add multiple Young's modulus and Poisson's ratio by going to add temperature. You can assign the Young's modulus and Poisson's ratio which are temperature driven as well, and you can plot the graph. like this. So you can see the variation of temperature and Young's modulus. If Young's modulus varies significantly with respect to temperature, you can of course govern your problem by assigning those material properties. And also you can see the Poisson's ratio versus temperature, how it is depending. So both the thing are depending on your principle. So let us see how to do this. If we go to material property and isotropic, I am adding 3-4 materials with a temperature 20, 40, 150, 300, and Poisson's ratio is 0.2, 0.35, 0.24, and it is 0.17, and Young's modulus is, let us say, 200, 250, 300, and it is 400. If you go to graph, you can plot based on Young's modulus, or you can plot based on Poisson's ratio. These are the things which are very, very important as far as the problems are concerned, like this. And you can copy the material from one model to another directly by going per copy. You can create the material template as well, which you can use directly from the stored problems. You can go to favorite and delete favorite also. So these are certain quick tips which you can use during the project to reuse the existing data time and again. And also you can list the properties of all material. So this is very, very important. You can go to list properties and all materials. You can see all the data are there which you can list, not only material but also other properties also. So if you define the material, all the properties will be listed here. Before going through material in depth, you have to understand certain principle. Let us start with the Young's modulus. As far as Young's modulus is concerned, you have primary single Young's modulus for homogeneous material. But if you talk about composite and orthotropic material, you have multiple Young's modulus. So you can define multiple Young's modulus if the material property so demands. And just like that, the Poisson's ratio also in XY, YZ and XZ, because Poisson's ratio depends on shearing plane XY, YZ and ZX. So section modulus is also introduced to understand this, like GXY, GYZ and GZX for shearing condition. So if you have orthotropic material, you have to simultaneously define the shear modulus and Poisson's ratio as well. Just like that, you have the minor Poisson's ratio also in XY, YZ and XZ plane. And you have mass density to define the material property. This is fundamental property when you execute or perform modal analysis or frequency analysis, because frequency analysis does not require external load. So that frequency will be calculated based on mass density, and you can apply the reference temperature, that is REFT, and also thermal conductivity along all the direction and coefficient of thermal expansion and so on. And also you have the convection coefficient HF, emissivity in your radiation problem, and viscosity for viscous fluid flow and so on. Multiple attributes also you can assign to a particular model, which you can see. If you have a beam that is controlled to certain real constant and is having certain material property, maybe material property 1, 2 or 3. So if you configure this, then only the attributes are set. How to do this? This is very, very important. You can directly go to the modeling, and when you go to the modeling, you can see here the create, and when you go to create, you can see the element and element attribute. So these properties you have to define very precisely and correctly. What about the real constant, what about the material property, what about the section number which you have, and what about the coordinate system which you use, and so on, and what about the element type you have. So all these multiple element attribute properties you need to configure in order to assign the correct attribute properties. And in the same way, you can define for any element. You can modify also the element attribute after meshing, and this property directly can be controlled through the dialog bus or through particular option. If you talk about the element type, I am adding a particular element, and if you go to the characteristics, you go to the section, you go to the common section, and if you want to edit this data, you can always do it. You let us say I am changing this, so to the A1 or the ID1, this new property will be set. So any sorts of changes you can do, either that is material or real constant, that directly can be done. And you can do this plotting control, which I have shown in my many of the exercises, like plotting control through the key point, through the line, through the areas, which directly you can find through plot control, numbering, and you do all the controls, like when you need to plot the points, you want to plot lines, areas, and so on. And when you assign the properties like this, the areas or key point, which directly you can see after filtering, once you set that option, that will be shown here, which I have discussed in my earlier classes also. Next, we will see the element attributes tables in our coming lecture, and we'll understand it in details.